Hi everybody, this video is going to be about section 6.2 from the Scott Stevens textbook, and it's titled Normal Distributions in General. So last video you guys learned about the standard normal distribution and things like which is a distribution of z-scores, and how to find areas under certain parts of that normal distribution curve. Areas to the left of that any z-score, areas to the right of z-scores, area between two z-scores, and also if you have a given area or probability, how to find the z-score from that. So in this video, what we're going to be doing is we're going to be applying those principles, but to regular variables, regular everyday variables that turn out to be approximately normally distributed. So recall the standard normal z-distribution has a mean of 0 and a standard deviation of 1. In practice, we're not dealing with a standard normal distribution. Instead, we have some normal distribution with a mean of mu and a standard deviation of sigma. So converting between such a normal distribution and the standard normal distribution is done by working with z-scores of the variable. So here, x is from a normal distribution. It's a value, a data value from some normally distributed data set. And z is the corresponding value from the standard normal distribution. Really, z is the z-score. And that's going to correspond to a value on the z-score axis. Okay, so let's do an example. Assume that adults have IQ scores that are normally distributed with a mean of 100 and a standard deviation of 15. We'll consider two types of questions demonstrated here. 1. Find the probability that a randomly selected adult has an IQ less than 125. And second, find the IQ score which separates the bottom 50% of the adults from the top 20%. And this is typically denoted by the symbol P sub 80, or the 80th percentile. All right, so problem 1. So problem 1 was find the probability that a randomly selected adult has an IQ less than 125. So what I recommend you do is to first draw your normal distribution curve, okay, which looks like that. Okay, and you're always going to want to put a mark at the center of it, which is at the mean. And so you can see here a mean of 100. And what we're interested in is the probability that a randomly selected adult has an IQ less than 125. So we're going to mark 125 in relation to 100, which is obviously bigger than 100. And we want to find the probability of an adult, randomly selected adult, having an IQ less than 125. So we're going to shade to the side of 125 that would be less than 125, which is obviously to the left. Okay, and what we're trying to find is the area of this region right here. Now, we learned last class how to find the area to the left, to the right, between z-scores. So what we can do is we can turn this 125, this IQ of 125, into its z-score. And so to do that, you just use the z-score formula right here in the box. So you do 125 minus 100 divided by 15, and that turns out rounded to be 1.67. So we're trying to find the probability, or the area, of getting a z-score less than 1.67. So we can then go to our table, look that up, and since it's area left, then it's just going to be the probability given by the table itself, and that will turn out to be 0.9525. Okay, cool. So let's go on to problem 2, which is find the IQ score which separates the bottom 80% of the adults from the top 20% of adults. So let's, again, always start these problems by drawing your curve. All right, and then you're going to cut this curve somewhere such that it would be split into a bottom 80% and a top 20%. Because you know these two areas have to be complementary. They have to add up to 100%. So what we can do is we know that the table in the back gives us areas to the left. So we go fishing in our table for an area of 0.80. And I would probably throw a couple zeros on at the end of here and make it 4 digits, just like all the values in our table. So we then go looking in our table. I'll pull that table up. And go fishing for 0.8000, which would be right somewhere between here. And you can see the closer of these two values would be the 0.7995. So we would say the z-score is 0.84. So the closest z-score is 0.84. And that's just a z-score though, and we're interested in finding the IQ score. So we then need to transform this z-score into an actual x value. And we can do that by this equation right here. This equation right here is just another form of the z-score formula. If you take your z-score formula, z equals x minus mu divided by sigma, and you just solve this formula for x, then you would end up getting this equation right here. So we're going to plug in mu, which was 100, z, which we just found to be 0.84, sigma, which we know is 15, and you plug it in and you get an IQ score of 112.6, being the score that separates the bottom 80% of adults from the top 20% of adults. All right, on to the next page. Your turn. Why don't you try this one yourself? Pause the video and give this example a try, and then when you press play, you can take a look at my solution and see if it matched yours. Okay, so again, we're working with IQ scores, which we know have a mean of 100, standard deviation of 15, and we're going to do two examples here. First, find the probability that a randomly selected adult has an IQ between 75 and 125. So first, I'm going to start by drawing my curve. And we know it's going to be centered at the mean of 100, and we're trying to find the probability of an adult having an IQ between 75 and 125. You don't have to be too accurate about where you put these. Just make sure they're relative. You know, the 75 is below the 100 and the 125 is above the 100, of course. So now we're going to chop our curve off here, and what we're trying to find is this probability in the middle. So we found last section that the way you find probability between two z-scores is you find the area for this z-score, the area to the left of this z-score, and the area to the left of this z-score, and you subtract them. So we're going to go ahead and do that. So now in order to do that, first we actually need the z-scores themselves. So what is the z-score for an IQ of 75? I'm going to do some work over here. So it'd be 75 minus the mean of 100 divided by the standard deviation of 15. And that's going to be negative 25 divided by 15, which would be 1.67, negative 1.67. So d equals negative 1.67. Okay, and then for a z-score of 125, we would do 125 minus 100 over 15. Ooh, that's an ugly division bar, which would be 25 over 15 again, which would be positive 1.67. All right, so now what we want to do is find the area to the left of this z-score, z1. We'll call that z1. And we'll call this z2. And what we're going to do is find the area to the left of z1, the area to the left of z2, and we're going to subtract those two values. So let's go ahead into our table. So flip back here. This is the first page of the table. So z1 was negative 1.67. So negative 1.67 is 0.0475. And the one for positive 1.67 is going to be on the next page. And that would be positive 1.67. 1.67 is 0.9525. So let's see if I can keep those in my mind as I go back here. So we had I think it was 9525 and 0.0475. So you subtract these two, and then you get 0.9050. And so that is the probability of a data value being between an IQ of 75 and 125. So it's basically the probability of this shaded region right here. Okay? All right. Example B, find the range of IQs which define the middle 50% of adults. So in other words, find P25 and P75. So I'm going to draw my curve again. Always start every problem by drawing your curves. So we know 100 is in the middle. And we're trying to find P25 and P75, which basically are going to chop this curve up such that, wow, this is really ugly. All right, so we want to chop our curve up so that we have our middle 50%. So we want this to be 50% of our data, the middle 50%, and we want to find these two IQ scores. All right, so this one takes a little bit of thinking, but you should be able to figure out that if this is the middle 50%, then what percent of my data is here and here? Well, the other 50% total would be here and here. So you got 25% here and 25% here. So how do we find this IQ score? Well, first we can start by finding the z-score for it. What's the z-score that corresponds to a lower area of 25%? Well, let's go into our table in the back, and we're going to go fishing in here for 0.2500. And that is somewhere around here. It's between these two values. And the 0.2514 is a bit closer to 2500 than this value right here. So we're going to go with the z-score of negative 0.67. So back to page 90. So this would be a z-score of negative 0.67. And you could go ahead and try to find this z-score right here by kind of a similar method, but remember the standard normal distribution is symmetric. So since it's symmetric and is the bottom 25 and the top 25%, this right here is just going to be the absolute value of our first z-score. So this will just be positive 0.67. All right, and now we want to find the actual IQ scores, not just the z-scores. So we can use our formula x equals mu plus z times sigma in order to find out the IQ scores. So x is going to equal 100 plus 0.67 times 15. So take a calculator out and figure that out. I'll pull one up right now. 0.67 times 15 is 10.05 plus 100 turns out to be 110.05. So 110.05 is the upper bound, and then if we do, so that's the upper bound, and then x equals 100 plus negative 0.67 times 15 to represent this z-score, to find that IQ score. We would get negative 0.67, negative 0.67 times 15 is negative 10.05 plus 100 is 89.95. Cool. So those are our two z-scores that would define the middle 50% of adults. All right, cool. So the last example in this video is your turn number 2. So again, pause the video, give it a try, and then see if your answers match up with mine. All right, so in this example, suppose you manufacture and sell ice cream by the pint. The weights of chocolate chunk pints are normally distributed with a mean of 408 grams and a standard deviation of 4.5 grams. So, you know, kind of just like this example, kind of more one that's more relevant to me in everyday life is, you know, you open a bag of chips or maybe a bottle of soda. And are all bottles of soda, do they all have the exact same amount of volume in them? No. And maybe sometimes you've even looked at a bottle of soda and thought, hey, this one kind of looks like it has a little bit less in it than usual, or maybe a little more in it than usual. So this is what's going on here. They can't exactly pour the exact amount of volume in every bottle. And same with ice cream pints. So the mean is going to be 408 grams, but there's going to be a little deviation from that, from pint to pint, and the standard deviation is 4.5 grams. So you, the manufacturer of this company, realize, well, you don't want your customers to feel screwed if they get, you know, one of those smaller pints. So you want to sell the lightest 5% of the pints at a reduced cost. So what weight should you use as the cutoff to determine which ice cream pints get sold at the reduced rate? So let's start by drawing our curve, and we're going to start by putting our mean in the middle here, which is 408. Right? So we want to sell the lightest 5% of these pints at a reduced rate. So the lightest 5% are going to be somewhere over here. Right? That would represent the lightest 5%. Okay, so we're trying to find basically what is this weight? What is this x value? All right, so we know that the probability here, we want to be 0.05, 5%, right? So we can turn this into a 4-digit decimal, and we can go fishing in the table for this probability. And when we do that, we're going to get back a z-score for this region of the curve, and that z-score we can then turn into an x value. So if you go back into your table and you go fishing for 0.0500, you're going to end up right around here. And in the middle of these two values would be 0.05, which we see a blue dot here, which you can then follow that blue dot, all the way down here, and see that the special value for that blue dot is where the area is 0.0500, and it says you should use a z-score of negative 1.645, which is really just halfway between negative 1.46 and negative 1.65. Okay, so let's go back to our problem. So we're going to use a z-score here of negative 1.645. All right, and now we can get our x value, the weight of the ice cream. So x is going to equal mu plus z times sigma. So in this case, the mu is 408. Our z-score is negative 1.645. And our sigma is 4.5 grams. So plug all these into the calculator. Negative 1.645 times 4.5 equals that. And then you add on your 408. And we get a weight of 400.5975. I'm going to round this to 0.6. And that would be the weight cutoff that you would use to determine which pints you want to start selling at a reduced rate. All right, so that's the end of this video. I will see you guys in class.